hence the change in temperature of a mixture can be found by subtracting the initial form from the final temperature. Okay, so this is the formula for calculating the temperature. So if the liquid started at 18 degrees Celsius plus minus 0.5 degrees Celsius and ended up at 25.0 degrees Celsius plus minus 0.5 degrees Celsius, then the change in temperature is. So it's asking to find the change in temperature. Okay, delta T stands for change in temperature. So we're going to do delta T equals T final, which is the 25.0 degrees Celsius minus 18.0 degrees Celsius. Okay, uncertainty, we just add them together, right? So the final answer will be a 7.0 degrees Celsius plus minus 1.0 degrees Celsius. Test number 9. So 10.0 centimeter cube of acid is delivered from a 10 centimeter cube pipette. We repeated 3 times. What is the total volume delivered? So we added 10.0 centimeter cube plus minus 0.1 centimeter cube 3 times, right? So the final answer going to be 10.0 plus 10.0 plus 10.0 centimeter cube plus minus 0.1 plus 0.1 plus 0.1 centimeter cube. So final answer is 30.0 plus minus 0.3 centimeter cube. Okay. Test 10. So if the question is asking us to calculate the total volume delivered, same thing. Total volume will be equals to volume final minus volume initial. Okay, so final volume was 38.46, initial volume was 12.15. So the final answer going to be 38.46 minus 12.15 plus minus 0.02 plus 0.02. Okay, then the answer will be 26.31 plus minus 0.04 centimeter cube. Make sure you have the same decimal place for both number, the pure number, and the uncertainty. Okay, so let's try to propagate the uncertainty for this question. Okay, so we are trying to multiply and divide the numbers with the uncertainty. So example here, we are trying to find the density of the object, and this object has the mass of the 9.01 gram plus minus 0.01 gram, and has the initial volume and final volume, and initial volume is 23.0 centimeter cube plus minus 0.05 centimeter cube. Final volume is 28.0 centimeter cube plus minus 0.5 centimeter cube. Okay, so the first thing that you have to do is finding the volume of the object. Okay, that's the first thing that you need to do to find the density of this object. Okay, so let's subtract. So the volume of the object is equal to final volume of the water minus initial volume of the water. Okay, the final volume of the water in this case is 28.0 centimeter cube plus minus 0.5 centimeter cube. Initial volume is 23.0 centimeter cube plus minus 0.05 centimeter cube. So we know the volume of this object is 5.0 centimeter cube, and uncertainty is 1.0 centimeter cube. Okay, next let's find the density. Okay, density is equal to the mass of the object divided by the volume of the object. Okay, so mass divided by volume. So the mass of the object was 9.01 gram plus minus 0.01 gram, and volume is 5.0 centimeter cube plus minus 1.0 centimeter cube. Okay, so to do this division, okay, when you do multiplication and division of the numbers with the uncertainty, what you need to do is you first have to convert all the uncertainties to the percentage uncertainty. Okay, so you first have to convert these absolute uncertainties to percentage uncertainties. Okay, after that you're converting it back once you're done with all the calculations. So to convert these uncertainties to percentage uncertainty, you have to do 9.01 gram plus minus. Divide this number by your number, okay, number in the front, and multiply by 100%. Same thing with the 5.0. times 100%. So you're done with this, right? Then simplify it. Then you get 9.01 gram plus minus 0.1% divided by 5.0 centimeter cube plus minus 20%. Okay? Then you get 9.01 divided by 5.0 plus minus 0.1 plus 20%. Then you get 1.802 gram centimeter cube plus minus 20.1 gram centimeter cube. Okay. But this is not the end, right? So now we are going to convert the percentage uncertainty to absolute uncertainty. Okay. So we are converting the percentage uncertainty to absolute uncertainty by multiplying your uncertainty with its number. Sorry, this is percentage. Okay, so you get 1.802 gram per centimeter cube plus minus 1.802 times 0.201. 0.802 gram centimeter cube plus minus 0.362 gram centimeter cube. Okay, then you can write this as 1.8 because we only have two significant figures for this question, right? So 1.8 gram centimeter cube plus minus 0.4 gram centimeter cube. Okay, rules for multiplying or dividing by a pure number. So this is very useful tool when you're trying to calculate the mass of this certain element with the uncertainty to something else. Okay, so here I have a 3.62 gram of the magnesium with its uncertainty 0.01 gram. Okay, and we are converting it to the mole. So when we convert the gram to mole, we had to use the atomic mass. Okay, so the magnesium's atomic mass is 24.3 gram per mole. Okay, atomic mass of the magnesium is 24.3 gram per mole. So to convert the gram to mole, you have to divide this number by this number, and then same thing goes with its uncertainty. Okay, so uncertainty is 0.01. So to find the proper uncertainty for this number, you are just dividing the 3.62 by the 24.3, right? So you do exactly the same thing. Okay, the uncertainty. Then you get your final answer 0.149 more plus minus 4 times 10 to minus 4 more.